Optical networking is often explained in many different ways, but in this video we use a simple, intuitive, real-world scenario, revealing the essential building blocks that come together to form a complete end-to-end communication link. By the end, you'll see how these pieces fit together to move data across vast distances at the speed of light. Imagine two buildings, 60 kilometers, about 37 miles apart, that need to share information at incredibly fast speeds, 10 gigabits per second or 10 billion bits every second. This is where optical networks come in, using light to carry information instead of traditional copper wires. At the core of each building is transmission equipment, such as a switch, an optical transmission system, for example, a transponder or optical line terminal, or a router. In this example, we will focus on the router. Think of a router as the traffic controller of digital information. It decides where data goes and gets it ready for transmission. But routers deal with electrical signals, not light. To send data across long distances through optical fiber, we need a device called a pluggable transceiver, often called an SFP. A transceiver has two main parts. Optical interface. This is where the transceiver connects to the fiber cable. It typically has two ports, one for sending light and one for receiving light. The ports connect to the two fibers in the cable running between the buildings through a duplex connector, such as an SC connector. One fiber will carry data out and the other will bring data in. Electrical interface. The transceiver's electrical interface connects to the router's host interface through the pluggable module cage. The pluggable cage provides the mechanical alignment, power and management connections required for the transceiver to operate within the router. Among its multiple connectors, the most important here is the one that handles high-speed data transfer. This is where the electrical signals from the router enter the transceiver. When your information, like a video, voice call or file, needs to be transmitted over long distance, the router converts it into digital data, a stream of ones and zeros. The transceiver takes this stream and uses it to modulate a laser, which means it turns the laser on and off in a pattern that matches the ones and zeros. This method, called intensity modulation with non-return to zero (NRZ) scheme, creates a light version of the original data. The modulated light then travels through the optical fiber, which can carry the signal for tens of kilometers without losing information. At the other end, the light enters the receiver side of the transceiver, where a photodetector, similar to a tiny solar panel, turns the light back into electrical signals. When the light is on, the photodetector produces an electrical current. When the light is off, no current flows. In this way, the original digital data is perfectly reconstructed and sent to the router on the receiving end. In short, the light in the fiber acts as a carrier. It's just a vehicle transporting the data from one building to another. The router manages the data, the transceiver converts it to and from light, and the fiber carries it across long distances at astonishing speeds. Even this simple setup shows how optical networks make modern communication, video calls, cloud services, and streaming possible. For anyone curious about technology, this is just the beginning of an exciting field where light moves information at the speed of thought. Explore more advanced optical networks by joining optical networking workshops offered by Optical Technology Training, OTT, and delivered by FiberGuide. Visit FiberGuide to discover our programs and find out how to participate. Don't forget to subscribe and to hit the bell to be notified when our next video is posted. And if you enjoyed this one, please give it a like. Thanks for watching and see you in the next video.